Greetings, geologists, and we're here to talk about hydrology and fluvial systems. Fluvial systems are river systems, and the study of hydrology looks at the movement, distribution, and the quality of water. So we're looking at quantity, quality, location, all of the above. Interestingly enough, hydrology is the wave of the future. If you're looking for a job that will be secure long term, I would put my money on hydrology, because water is an essential need for everything to occur in life, from living organisms to survive to manufacturing and everything in between. Fluvial systems are actually divided into segments according to the Environmental Protection Agency. These segments are then drawn to show watersheds. For example, here's your main stem, and then you have main tributaries that feed into it and smaller tributaries that feed into the tributaries that get to the main stem. Eventually the main stem feeds into something. That something would be like a lake, maybe an estuary, a wetlands, a swamp, or the ocean, for example. And we measure hydraulic systems based on their flow, and we look at the flow and the water quality analysis from samples we take from upstream to downstream to look and see if there's trends regarding the change and the health of that particular river system. Now, streams are amazing shapers of the landscape. Now, before you get too worked up over the fact that water cuts down rock, and we all know that, you're like, oh yeah, I knew that answer, yay. Let's talk about how it does it. Water itself will erode down material over time, but it usually needs some help. It's what the water carries that's the magic behind the erosion process. So the suspended bed load and suspended load that grinds the bottom, that actually causes most of the erosion. That's the Grand Canyon, and you look at that and you can see massive erosion where material that's been taken out that was part of this wall to the other canyon wall has been completely removed. So you have to imagine that went somewhere. That material got deposited downstream in lakes primarily, and human-made lakes at that, which are used for drinking water and power sources. So you have to wonder what's going to happen to those lakes. I'll give you an example. Lake Mead in Las Vegas. Lake Mead's on the brink of its last leg, and that's a massive water resource, not for just Las Vegas, for a number of communities and big cities, and certainly irrigation for agriculture out west. So let's define some terms that you need to know for fluvial. Watershed is the first term. A watershed is a drainage basin in which everything from a high elevation drains to the common low area. So this is the Bosque, and actually it's the North Bosque watershed. You'll often hear people refer to it as the Bosque, but I want to kind of give you a little FYI about our area. The North Bosque is the main tributary that feeds into Lake Waco. There are actually 3 other tributaries that feed into Lake Waco besides the North Bosque. The Middle Bosque, the South Bosque, and Hog Creek, respectively, all flow into Lake Waco. But this one right here constitutes 75% of the flow. And the boundary marker you see around here would be the high elevation area where everything drains down into the middle of the watershed. So let's say I have a manufacturing plant in Dublin. Let's say I have dairies up here, which is certainly the case. Let's say I have pig farms right here. Let's say I have a leaking septic tank right here. Let's say I have people that over-fertilize their yards in Clifton, for example. All of this is going to be picked up by rain and worked downstream to the end user, which is going to be Lake Waco. If you were a Corps of Engineer person, you would actually say Waco Lakes. If I have any Corps of Engineer folks listening, I know that it's Waco Lake. Habits are hard to break. But Lake Waco, Waco Lake, one and the same, receives the water from all of these river basins, and the quality of that water matters because everything within a watershed, within this boundary, the high mark down to the low section right here, is going to pick up any pollution that may be there. The watershed divide is that high point I was showing you just a second ago. That's everything's draining into the common body. So on this side of the watershed divide, there should be another watershed next door. So each watershed is separated topographically from another one. The absolute largest divide in the United States or North American continent is called the Continental Divide, and you can actually see it many places along the Rocky Mountains and Cordilleran Range. So some other terms you'll need to know for this unit. River. You're like, oh, that's easy. A river is a waterway that transmits water from high elevation to low elevation. So you need to think about that because this is actually a highly missed question on the test. Rivers help recharge groundwater, and groundwater actually discharges back into rivers. So there's some places along certain rivers, in particular out west, where groundwater is a major influence for how and when a river can flow. The headwaters of a river, if this is the North Bosque watershed right here, the headwaters would represent this section right here, and then the mouth would represent where it feeds into another water body, in this case Lake Waco. So headwaters are the furthest upstream tributaries of a river system. Subsequently, they're usually the smallest, and they gain size as they continue down and get fed by other tributaries that feed into the smaller ones that actually feed into the main stem of that system. The mouth of a river is where it discharges into a water body. In this case, I'm on the Oregon coastline, and I'm looking out where a river is discharging into the ocean, in the Pacific Ocean there. And this would be a classic mouth where the water slows down because the land gets real flat. The dip's real, it's just very flat. There's hardly any grade at all. And so the water kind of spreads out, and all of the finer grained sediments begin to settle out, making deltaic type deposits. So a mouth would represent the furthest downstream area where it feeds into a river, lake, estuary, ocean, or sea. A floodplain, another highly missed question on the test, is an area that floods adjacent to a river. So if this is my tributary right here, and it is, if you can follow the tree line all the way around this way, what's happened is this section right in here has spilled out of the waterway because it got high flow conditions. This is actually important, and you can note this is like an agricultural pasture here, because this is going to get all the nutrients that came out of there and deposit them along these edges. So floodplains can be very fertile land as a consequence of being flooded repetitiously. Riffles, and that is not a mistake, that is actually a correct pronunciation of that. Riffles are I-F-F-L-E-S. These are shallow stretches of areas or stream that are above velocity in their speed and flow, but lower in average in depth. And so what happens is they look like little ripples with P's, but they're actually called riffles. And they're very important for a number of reasons, because they actually help with the types of living organisms that can live there. Certain animals live under those rocks, not to mention that they can act as important erosion features for being picked up. Those cobbles and pebbles and boulders that get moved with certain flows of water and act as an erosion agent. Runs are different from riffles. They are higher than average velocity, Runs are higher than average velocity and higher than average depth. So the one difference from a riffle, higher than average depth. So these areas that are fairly deep, you can see in the river that goes on the road called Going to the Sun in Glacier National Park. This section is very deep, and so this would be considered a run. Where it's shallow enough to see what you saw in the prior picture, these little things right here, those would be called riffles. Pools, however, are lower than average velocity, so you can start to develop deposition of finer grained sediments because the energy has basically stopped, and so they can be kind of murky, especially if you mess up the bottom or fish start moving around. Pools are very important for aquatic life. So you got to have each and every one of these types of things for a really good functional fluvial system to work. Now let's talk about a meandering stream. A meandering stream is what you see here, where it makes a sinuous curve back and forth, where you get what are called a series of cut banks and point bars. Cut banks would be like what this area is right here, and a point bar is the adjacent area where the flow is the lowest, and we're fixing to cover those. This particular meandering stream I saw right outside of Lassen Volcanic Field, and was very much impressed by the fact that it was a little tiny one actually in terms of width, but it was classic meandering. So when you get a meandering stream, what will happen is the section that flows the fastest will create a cut bank, and directly on the other side the flow is slower, so it begins to deposit sediments. So for every cut bank across the way, you should have a neighbor that is a point bar. Same would be true here. You get this cut bank right here, point bar should be on the other side. So why do we really care about point bars? They're economically viable resources for gravels that we use in construction. Here's an example of a cut bank and a good look at how dangerous cut banks are. So you wouldn't want to be walking on something like this. If you were coming from this direction walking this way, you wouldn't think much about that overhang. Well, you could easily exceed the weight that this slope could support and the whole thing crumble and mass waste. So cut banks can cause the level of water to rise very quickly as that energy in a higher storm begins to eat away this fabric. And that's one reason the fabric of a stream constantly is in a change. Stream beds don't stay static. They constantly change location. So we have a lot of ancestral river deposits along something like the Brazos River, for example, in Texas. And we use those for economic viability and go looking for them so we can harvest them for money. Point bars would be like what this thing is right here, and these types of deposits that you see along the edges, or this one right here. These are the shallowest part of a stream. They're on the opposite side from a cut bank, and they actually are going to be where the lowest flow energy would be. So can you tell where the point bar and the cut bank are located? If you pointed to the white things as the point bars, you were dead spot on. If you pointed to the curves as where the cut banks are, like this is a cut bank, this is a cut bank, that's a cut bank, and all the white things you see, those are point bars. Where are the point bars in this one? Like it's the white things, you're right. And where are the cut banks? Directly across the way where you see the meanders. So occasionally we can get a meander that grows substantially and it begins to be more difficult for the river to travel, and the water will always find the path of least resistance. When that does it, it can cut off one of these meanders, and we'll get to that in a minute. It's called an Oxbow Lake. So here's a cut bank. This was in the site of the mudslide that occurred in March of 2014 in Washington State. And you need to see this landslide right up here and how it actually slid into the river and actually dammed up the river. So that could be a bad thing because now we already had sediments that were there from some of your point bars, and then we get this entire cut bank that are and point bar that are absolutely inundated from a landslide. You are looking at cut banks and point bars. The cut banks are the areas that have been carved out by higher velocity flow, and the point bars are on the opposite side of the cut bank where the velocity is lower, and so it subsequently deposits sediment. So wherever you see a point bar, you should also see a cut bank on the other side. So that moves us on into braided streams. We're not going to see braided streams down here in central Texas. You might see some along the Red River where the boundary between North Texas and Oklahoma are. But most braided streams, geologists, are formed from melting glacier water. So you're going to see a variety of stream channels because the water flow is so slow. So I took this from the air as I was flying over towards Queenstown in the South Island of New Zealand. And as I flew over, we were coming off of the Southern Alps, and the Alps were draining meltwater from glaciers into the valley areas. And that's what all this sediment and silt is from glaciers. And you can see how the river has made multiple different braided streams as it comes down. So if you see something like that, you know indicatively, or if you see something like that, you know that it's indicative of glacial meltwater. So most braided streams are associated with that type of depositional environment. So I mentioned an Oxbow Lake a minute ago. An oxbow is a U-shaped water body formed when a wide meander gets cut off. So you have to expect this one's probably going to do that pretty soon. But do you see this thing right here? That's a classic oxbow. So we got the water's going to find a new path of resistance, and I bet you what's going to happen is it's going to try to come right across this section right here. And when it does, this whole thing will be another one of these right here, and it'll be cut off from the main stem of the river. So eventually it'll fill up with sediment, it'll dry up, and it will not be very productive, usable water for very long if it doesn't get influence of good, strong, fresh water coming into it. This is a beautiful Oxbow Lake called Horseshoe Bend, and it's in Page, Arizona. We go there on our geology field course. Pretty spectacular, isn't it? Bradley Turner took this picture for us. He's our main photographer and sponsor of our field course. It's been going for years now, and he took that picture, and it's absolutely spectacular. And you look at those rocks, you're like, wow, or you're going to learn about what rock formation that is, an aeolian. But that's an oxbow in the makes. Can you see that same profile of a shape? Well, eventually this river's going to, the Colorado is just going to cut through that area, not through this rock right here, but right around this area right here behind it. Another point I might show you about this picture is differential weathering. Why is that big rock right smack dab in the middle, and has it not weathered down? It's an interesting thought to think about, isn't it? So another feature for rivers are deltas. Deltas form where the mouth of a river flows into the ocean, and you can see that's just where the mouth is, and all this material that you see built up is deltaic deposits. As an FYI, for those of you who are familiar with Washington State and a famous area called La Push Beach, that's where this is. It's right in Olympic National Park, and it's really a spectacular beach line to behold in Washington State. So I want to leave you with a couple of thoughts of thinking about river systems and how they apply to you. You're like, oh, well, it's no big deal for me. I drink out of Lake Waco. Why should I care? What if this kind of pollution was getting into rivers that flowed into Lake Waco? Would you be concerned? I'm not saying that's happening, but I can tell you I used to work for the Brazos River Authority and Texas Commission on Environmental Quality. On occasion, things get into the river system that are not good, and that's coming down to our drinking water system. So you should want some kind of control over that type of pollution and enforcement for entities who are constantly causing problems. So be aware that non-point source pollution basically means pollution you can't trace back to the source. In this case, we can probably trace it back to the source from a pipe, but if it was washing off from all of this stuff back here, I wouldn't be able to trace it to a single location. Look at the water in Oak Creek Canyon from this summer on my sabbatical, and you're going to notice how red it is. Well, that's sediment that washed off during a flooding event. Sediment's got a whole slew of environmental and health-related problems, so I wouldn't want to be drinking out of that water. And you have to think about those are some of the things we're worried about with our river systems and fluvial systems. So a point source pollution is something just the opposite. It is right out of a pipe. You can trace it back to its actual location like you can this wastewater discharge right here. As an FYI, all point source discharges are regulated in the United States. Not some non-point sources as well, but that didn't really start until the 90s when we started regulating non-point source. We regulated point source starting back in the 70s. So as we conclude today, we're at the end of the river, or the fluvial system. This is a river that is in Grand Teton National Park. It's a real famous area, a great wildlife viewing area, including moose. And you would want to see the variety of different parts of a river in this area, and you can. If you follow the river, you can see runs, you can see riffles, you can see point bars, cut banks. If you look at areas, you can find some deltaic deposits. These are all things you're going to need to be familiar with terms with fluvial. So I will see you at the next lecture. Bye.